all, welcome back to the tutorials. So we have been talking about I2C communication in the last video. We'll continue the discussion on that. Uh, just to add few more points regarding the I2C communication. So basically, there are some devices called I2C bus repeaters which are available from manufacturers like NXP, where let us assume a scenario like a standard mode of I2C communication where we have been mentioning that the maximum capacitance allowed is 400 PF, and when you run a device the R&C product of R&C should be such that you have a specific rise time which need to be met. Now let us assume that I have multiple devices and the bus is run for a longer distance, and my capacitance has exceeded beyond the allowable limit. So in such cases, your design cannot stop working, or you cannot abort your design. You have to continue to find out ways where you can reduce the capacitance so that you can talk with multiple slaves that are present. So this is the scenario where I2C bus repeater shall be used, where there shall be an I2C input and you get I2C output from the repeater. This repeater, just to mention in a basic terminology, acts like a isolator where the input I2C is isolated from the output I2C, and hence the capacitance effect or the capacitance gets reduced. In Also this helps to isolate this section from this section, and input section and output section, and this helps to eliminate any noise interference from one section to the other. So there are many advantages of using this bus repeater. One of the major advantage which we have mentioned is mainly the capacitance limit. So now, one of the major scenario which we talked initially, that there are multiple devices and longer I2C bus which is run on the PCB. Other than that, one of the scenario where you might have to have a longer I2C is having to run a I2C onto a PCIe slot device. So in the computer, if you see, there are PCIe slots for adding cards. So in the future tutorial we will talk about PCI. So for now, assume that PCI is another bus which is used to communicate to backplane. One of the major application of PCI is backplane communication, and when you insert some daughter card onto that PCI slot, the bus extends from the actual board to the other board where the bus is run for a longer distance. So in such cases, you might have to use the I2C bus repeater to maintain that signal integrity. So that is one application. So this is how the I2C bus repeater you will use across your design. So we have to look at the respective data sheets to further understand the constraints of these devices. And then we just wanted to list some of the important points to remember in I2C here. One of the thing in I2C is that we are saying that there could be multiple masters and multiple slaves that can be connected over a bus, but at any time only one master can communicate with one of the slaves. So only two devices can talk at a time over I2C bus, even though there are multiple devices that are present. So this helps in collision free communication, and eliminates any errors that can occur over the channel. So that's one of the major advantage. And then we have to accept that from the beginning we are talking that I2C is a address based communication where you will address the slave, which is done by the master, and then based on the slave that is selected, the master starts communication with the slave. So now there is only addressing scheme for the slaves and there is no address for the master. So that is one of the important point we have to mention. So once the master initiates a command and sends a data to a particular slave, the reply is received by the same master. And then even though the other masters on the bus hear it, there is no use because they have not shared any data, so they will just ignore those whatever the comments that are coming. So now we can say when slave replies back or master communicates, it's a universal communication. Like master sends it over the bus, all the slaves will receive, only respective slave will respond if the address match. And one more important thing with respect to I2C is I2C is just a two-wire communication with just two pull-ups from the hardware perspective. Now this is very simple and you don't need any additional configuration. What you need is a slave with addressing specific address. So once that slave is connected, the master communicates to it. Now in future if you want to add any slaves, it's very easy to add on to the bus. Only thing we have been talking is the capacitance and hence the rise time that is associated. Otherwise the master can go on adding the slaves to the bus. And then one of the important feature in I2C is that it is resistant to spikes and noise. We have seen in the previous video that there's a spike filter that is inbuilt where it can restrict 50 nanosecond spikes that can occur. So this is one of the important feature on the I2C bus. And one of the most important point is that I2C is the most popular protocol in embedded systems. So any microcontroller if you take from a low end microcontroller like a 8-bit microcontroller available in the market to high end performance intensive microcontrollers, or if you take processors or FPGAs, I2C is present across all these devices. And it is hard to pick a microcontroller which is without a I2C interface, except that a very small microcontroller. So this is what how popular I2C is, and there are many slaves that are available to be connected across I2C. So these are the some of the points which you have to remember while using I2C. Thanks for watching. Keep visiting our channel for more videos. Thank you.